Welcome to the session. Myself, Sivaya B, working as a scientist at Indian Nation Center for Ocean Information Services in Kois, Hyderabad. So, in this session, we're going to see climate change, especially from ocean's perspective. So, if you see this diagram clearly tells you that the whole idea of the climate change. I mean, basic major causes, changes, and for the consequence of climate change. So, if you see the first dark blue circle, that indicates the major drivers of the climate change. I mean, major causes of climate change, like greenhouse gases, etc. So, because of these major causes of climate change, what kind of changes that we can get to currently existing climate? Okay, like what kind of changes we can see? So, melting of ice, rising sea level, this kind of, right? This is shown in here in the second medium blue circle. Okay, so when there is a change in the current existing climate, obviously you can get some consequences, some impacts. So that are shown in here in the light blue circle, the uh, third light blue circle, you can say. See, so flooding of coastal regions, damage to marine ecosystem. Okay, risk water supply, this kind of. So the first dark blue circle indicates the major causes of climate change. Second medium blue circle indicates the major change in the current existing climate, and third light blue circle indicates the major consequences of this climate change. Okay, so we will discuss all in a detailed manner in further slides. But before going to that, I just want to tell you that one scenario that what weather versus climate. Of course, most of the people who belong to that earth or atmospheric science related, they might have full aware of this. But many of people I have seen that people used to say today climate is very good, today climate is sunny, today climate is cloudy. So actually, in scientifically speaking, uh, that is not correct to say today climate is sunny like that. We always have to say today weather is sunny, today weather is cloudy, today weather is rainy, like that, because the weather is instantaneous atmospheric condition. So if you are talking about the instantaneous atmospheric condition, then that mean you are talking about the weather. Here instantaneous in the sense couple of hours, couple of days, or a week, like that. Okay, but coming to the climate, the average weather conditions at that particular place for a long period, like more than 20 to 30. Okay, so if your average the other conditions at one particular location for more than 20 to 30, then we can say a climate. For example, if you are planning to go to Kulu Manali, so then you have to see, in that scenario you have to see what would be the climate of the Kulu Manali by the time I go there, like for example during winter. So during winter, what is the average temperature of the Kulu Manali? That will be a climate. Okay, what is the temperature of now at that location? That will be a weather. So this is a basic difference between the weather and climate. So if whenever you observe the change in that weather conditions, average weather conditions at that location, so that change we call it as a climate change. For example, from last uh, uh, 2 years, you have been continuously observing a drastic change in the average temperature of the Hyderabad. For example, since last 10 years, okay, 2010 to 2020, if you take 2010 to 2015, the average temperature at Hyderabad, especially in Pragati Nagar, for example, the average temperature is not that much changed, like plus or minus 0.12 degree. Okay, then there is no issue, no need to worry. But from last 5 years, 2015 to 20, 50, 17 to 20, 22. So if you change a drastic, if you observe the drastic change more than 1 or 2 degree of average temperature at that location, that means the average temperature, that means what? Climate. The climate at that location is been changing. Change in the average weather condition is nothing but the change of climate. That's why we can say the climate has been changing with respect to time. Okay, we'll see in a further slides what are those all causes and all. So if you see the major causes of the climate change or major drivers of the climate change, one is greenhouse gases most among all. Of course, we have other drivers or causes of the climate change. That is volcanic activity, Earth's reflectivity, orbit and rotation, reflectivity or absorption of the solar radiation, etc. But first, we will see what is the major cause of the climate change. That is the greenhouse gases emission. Of course, we know greenhouse gases are nothing but the gases that trap the incoming solar radiation and keep the Earth atmosphere warm, right? Because of these gases only, our Earth atmosphere is like a warming, other than uh, all planets. Okay, so because if there are no any other greenhouse gases, that's also a problem. If there is a huge amount of this concentration of these greenhouse gases, that's also a problem because we cannot tolerate extreme cold temperatures and extreme warm temperatures. So what we have to do, we need to keep these concentrations, greenhouse gas concentration of these greenhouse gas emissions, we need to keep in the a moderate manner so that everybody, every living or non-living creature on the earth can sustain, right? Because what is the basic job of these greenhouse gases is like a heat trapping. So whatever sunlight is coming from the sun and falling on the earth, so they will trap the heat by not escaping that sunlight to space. Okay, so when these concentrations are very much high, so obviously the warming will be high. When the concentrations are very much low, obviously the cooling will be very high because they'll only trap the little amount of the heat. Like, because of that, we have to always keep this concentration in a limited manner. Of course, we know what are those gases like carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and different sources. Of course, you know that. Uh, but among all these greenhouse gases, carbon is again one a major gas. We have to always worry about that because carbon is a form everywhere you can see in all kind of formations like from living to non-living. Carbon is such an element. And one more another reason because why we are worry about carbon dioxide than other gases like nitrous oxide and methane and all, because the carbon dioxide has a high residence time. That means it can sustain, it can live a longer time in the atmosphere. Okay, so that's why we mostly worry about the carbon dioxide, how much amount of the carbon dioxide has been released into the atmosphere for every year or with respect to time and all. Okay, these are some graphics you can see by gas how much these emissions are, like what is the contribution of carbon dioxide, methane, nitrous oxide, etc. And similarly by the economic sectors, like from different sectors like electricity, heat production, transportation, industry, like from different sectors how these emissions are, you can see. And similarly from different countries around the world how these emissions are going on, you can see from China 30% is, China is contributing 30% of these emissions, and similarly others 30, United States 15, like this. Okay, these are some basic statistics of how these emissions are. And what else, as I told, like other than greenhouse gas emissions directly from both man and natural sources, what other causes of the climate change? If you see a volcanic activity, so when there is a volcanic eruption, what you can see, the huge amount of the water vapor gas will be released. Okay, and also carbon dioxide. So obviously because these again are the heat trapping gases, then you can see resultant warming effect. And when volcanic eruption is happened, you can see huge amount of the dust also, like ash particles, aerosol particles. So you, what do they do, these huge dust particles will block the sunlight by not reaching the earth surface. So when there is no sufficient sunlight not reaching the earth surface, thereby you can see some kind of cooling effect. So if you see in a historical events, volcanic eruption activities, you can see the most of the time a cooling effect uh, has created than warming. Okay, so like that, when see this is the activity, so obviously this cause either warming or cooling. So when there is either warming or cooling, obviously it lead to change in the climate. That's why it will be one cause of the again climate change. Similarly, Earth reflectivity, orbit, and rotational period. So in scientific terms, I can say these are the Milankovitch cycles. So when there is a change in the periodicities of these cycles, obviously because of these Milankovitch cycles and all, we can see what you can say seasons, length of the seasons. So obviously when there is a change in these periodicities, obviously there will be a change in these changes in the seasons and length of the seasons, as well as the amount of the sunlight that is falling on the earth, that also can be changed. So now obviously when there is, for example, for a unit place of the earth, if you are um, receiving the x amount of the sunlight, then you can see some kind of temperature. And now because of the change in these periodicities, the two times of the amount of solar radiation, now it's reaching the unit place of the earth, then obviously there will be a huge amount of change and huge amount of warming is kind of, right? Similarly, reflectivity or absorption of the solar radiation. So this is based on the how the Earth's landscape we are changing from time to time, every time with our activities like agriculture, road construction, deforestation. So, for example, if you have a huge forest, a dark forest, then obviously some amount of the heat will be trapped inside that. So there will be a warming. But if you cut the all trees and you make it like a deforestation whole area, then what will happen? So since it's not such a dark, so it cannot absorb such a huge amount of heat, which reflects back most of the sunlight to the space. Then obviously you will get the less amount of warming. I mean cool, less amount of heat. Thereby you can get some kind of cooling effect, right? So by this way, by the way we change our landscape of the earth with our activities and all, so thereby you can get either warming or cooling effect, thereby you can see some change of climate. So these are all the possible causes of climate change that first either create either global warming or cooling. So because of that, further changes will happen in climate at that locations on earth. So thereby we can say climate change. So coming to the ocean's perspective, as I told already, among all greenhouse gases emissions, the carbon dioxide is one is the most important gas among all. So what will happen since we humans or other natural sources or the sources for these greenhouse gases, right? So who will be the sink? Say if we are producing, who are receiving? Who are receiving these released carbon dioxide concentrations? Obviously as ocean, right? If we human beings or other natural sources or the sources for carbon dioxide or greenhouse gases emissions, so ocean is the major sink to dissolve that carbon dioxide. Okay, so what will happen when this carbon dioxide is absorbed by the ocean? So obviously ocean's temperature will increase. So because it's again heat trapping gas, when it dissolves with ocean or when it is absorbed by the ocean, ocean temperature will increase. Again similarly, when this I mean when the carbon dioxide is dissolved with the seawater, obviously it will create carbonic acid. So thereby you can see the seawater acidity will change. The seawater will become more acidic in nature. That means by reducing the pH. If for example in if your if seawater pH is 8 now, then if you mix some dissolved carbon dioxide in the seawater, it produces the carbonic acids and reduce the pH from 8 to around 7, 6.5 like that, and then seawater becomes more acidic in nature. Okay, and similarly when ocean water becomes more warmer, what will happen? The dissolved oxygen solubility will reduce. The capability of solubility of the seawater to dissolved oxygen, that will reduce. For example, if you mix the dissolved oxygen in cold water and warm water, so which water the dissolved oxygen will be highly dissolved? Obviously in cold water, because in the warm water the solubility of the gas will be less than the cold water. So as the ocean temperatures are increasing, obviously the solubility of the dissolved oxygen will reduce. So what kind of, because of these changes in the ocean, what kind of further consequences that we can see in the ocean's perspective? Obviously if you see first we will see in the ocean temperature. If what if ocean temperatures uh, rise? So obviously we can see ocean warming. We can see the phenomena effect of the ocean warming. So if there is a ocean warming, it leads to uh, melting of sorry, it leads to uh, cause the melting of ice in the sense land ice or a glaciers. That means what kind of ice that we see on the land near to the poles, a Greenland kind of. So when there is a huge amount of melting of ice, the melted water that will add up in the sea, there will be obviously rise in the sea levels. Because since extra amount of the water that is uh, uh, coming from the melting of ice and adding into the sea, so thereby you can see sea level rise. So similarly, when there is a change in temperature, so ocean circulation also will change because of the change in the temperatures. Because how? So if there is a change in temperature, that leads to change in the pressure in the overlying atmosphere of the ocean, right? So whatever atmosphere which is overlaid on the ocean, so there will be change in the pressure of that atmosphere. So change in pressure lead to change in wind, change in lead to change in ocean currents, because ocean currents majorly driven by surface ocean currents are majorly driven by surface winds. When there is a change in that wind pattern, obviously that lead to change in the ocean currents, right? Similarly, the global conveyor belt. This is global conveyor belt means is a kind of a major global ocean circulation from top to bottom of the ocean. Three major it's kind of a major ocean circulation from top to bottom in the three major ocean: Pacific, Hindu, Indian, and Atlantic Ocean. So this is majorly driven by the density of seawater. So the density of seawater again majorly driven by the temperature and salinity, right? So when there is a change in temperature, that also lead to change in density. Again, that lead to change in the movement of this global circulation, what we call like global conveyor belt or thermohaline circulation, right? Similarly, extreme marine ocean weather and coupled events. So these kind of events will also accelerate. This means what kind of events like storm surges, like cyclones, storms like hurricanes, typhoons, heavy rains associated heavy rainfalls, marine heat waves, and climate modes like ENSO, El Nino Southern Oscillation, North Atlantic Oscillation, Pacific Decadal Oscillation. This kind of all events will increase because as we know, I can say one example. See, since warm water is a key element for formation of the fuel for the cyclones, right? As the ocean is warming more and more in future, then what will happen? The amount of the frequency or intensity of cyclones will increase in time in coming future, right? Like this way, we'll discuss all this in a further slides in a detailed manner. And coming to the coastal ecosystem, so when the temperature rises, when the ocean temperature rises, then what will happen? When the ocean temperature rise, obviously it also damages the coastal ecosystem. Because a coastal ecosystem in the sense what kind of greenery we can see, uh, um, what kind of coastal habitat or greenery we can see in the coast, that like mangroves, salt marshes, sea grasses, coastal flooding, erosion, saltwater intrusion, this kind of. So when these all disturbed with this increasing ocean temperatures, then obviously coastal system will be damaged. Okay, and coming to the acidity, as I told, when the carbon dioxide is dissolved in seawater, it forms the carbonic acid, thereby it causes the seawater more acidic in nature. Okay, what will happen? So because of that, as I told, coastal ecosystem is a kind of ecosystem that we can see near the coast, but marine ecosystem is kind of ecosystem that we can see in the whole ocean, like marine species, like because of this acidic nature of the seawater, there will be change in the geographical range of the species, marine species. Means they used to go from, actually every year they used to stay at one location. Because of changes in the seawater in terms of acidic nature, they leave that place and they go some other places, right? So that we can say like a marine species migration. Thereby you can see some kind of change in the biodiversity and abundance of the marine species. Like earlier at that location, huge amount of, say for example 1 lakh species used to be there, but because of the change in seawater, now only 1000 species, like lack of abundance of marine species. This kind of changes also we can see because of this uh, acidity of the seawater has been as it is increasing with respect to time, right? Coming to the ocean acidification, as I told, because this is one of the special topic. Why? Because right now we've been seeing this coral bleachings because it's a coral reefs or the beautiful one of the beautiful marine ecosystem because these are continuously damaging and corals are continuously dying since last couple of years because when there is increase in the ocean acidity, so corals unable to form their outer shells like reefs, outer shells like with calcium carbonate. So when the water is more acidic in nature, it also dissolves the whatever outer shells. It also dissolves the outer shells and outer parts of the marine species, but and also unable to form any kind of outer cells because that water doesn't useful to create um, their outer cells with calcium carbonate because since it's the seawater in acidic in nature, so that may not useful to create and but also it dissolves the whatever already created cells and all to protect, thereby they lose their protection and their survival like this we can see in a detailed manner. And the last one is the dissolved oxygen solubility. That means as I said, when there is a when the seawater is unable to dissolve most of the uh, mm, uh, dissolved oxygen, when there is a change in the reduce the solubility of dissolved oxygen in seawater, obviously you will see the less dissolved oxygen in the seawater. So when there is a uh, oxygen concentration in the seawater is very less or reducing, thereby you can see no more any marine species can sustain in that because if there is no oxygen, there is no any marine animal or a marine species cannot sustain without oxygen. Thereby you can see kind of as the ocean dissolved oxygen reduces, then obviously you can see some kind of ocean dead zones. That's why we name it that phenomena as like a deoxygenation. So since even small change in the dissolved oxygen concentration in the seawater in a location, so that can affect the tissue level impact in the marine animal. That's why we call this phenomenon as like hypoxia. Even small change in the dissolved oxygen content in the seawater can change the tissue level impact of marine species. That's why we name this phenomenon as like hypoxia. So these are the possible impacts of the climate change, especially from the ocean's perspective. That all we see in a couple of slides, and this is the possible some of the important records I can say different from sources from recent IPCC. What kind of you can see these are the blue color indicates a major ocean's perspective. Of course, we have discovered more than that. Like we not only covered sea level rise, floods, and coral reef, but also covered other terms like circulation, extreme events, and all in a detailed manner. In a further slides, we will discuss all this in a detailed manner. Okay.